Today we're talking about determining speeds on the roadway. Now, most people have questioned the speed limits on roadways or how they're even determined to exist, or how does one even determine what the speed should be on a given road. So I'm going to give you maybe four different possible ways that municipalities or designers use to determine what the speeds should be on the roadway. Now remember, the posted speed is usually anywhere from 5 to 10 miles per hour below the actual design speed. But regardless, the posted speed is the rule of the land, and so we have to follow that rule regardless of what the design speed is. All right, number one. Here is a roadway center line. So this is if you're looking at it, a bird's eye view, horizontal curves are shown right here. And one way the speeds can be set is from the design or the necessary design that exists on the road. So let's just say, you have a horizontal curve here, and you got another one right about here. And each one of these curves has an associated radius. And that radius, if it can't be changed, if it's a set in stone type of radius, just based on the amount of spacing that one may have, you must use that radius. Then the radius can be one of the things that is used to determine the speed. Just by simply using, if you can remember back, the minimum radius equation, where you have speed on the top, you have this multiplication factor here, and then you have your super elevation plus your side friction factor. But if you have knowns here, and of course this needs to be unchanged, then you could solve for your speed, and that may be one way to do it. There are other ways. Another way is just using guidelines. Municipalities may have guidelines, or certainly the federal government has guidelines on the types of speeds that should be used on certain types of roadways. And so if you think about guidelines, if you're just going off of the guidelines and a certain number of vehicles that are expected or are traveling on that roadway, then you would automatically assign a speed based on the number of vehicles that are expected to travel. Or the roadway type. If it's a high functioning type of roadway, say a freeway or a highway, a multi-lane highway, then they may automatically get assigned a certain speed based on the classification of that type of roadway. And then the last thing to think about in terms of assigning speed by guideline is the location. Certain areas have a certain type of speed just based on their location. Then you have this thing called the 85th percentile speed. And so the 85th percentile speed is a reactive type of way of setting a speed. And so this roadway already exists. Vehicles are already traveling on this roadway, and people are recording the speed of the vehicles as they pass through. And what they use is the speed that is most traveled to set the speed limit that should be on the roadway. So an example of this may be a roadway that may feel like it should be traveling or should have a posted speed of 45 miles per hour, whereas the posted speed limit is only 35 miles per hour. But if most vehicles are traveling what it feels like as opposed to what it actually should be, then you have a situation where there's a variance in speed. And so you have the people who are obeying the law and traveling 35 miles per hour. And then you have those that are traveling what it seems to be comfortable 45 miles per hour. So you got that 10 mile per hour difference. And that's a potential, and it increases the chances of crashes to occur. And so to decrease that potential for crash to occur, they would use the speed that most vehicles are traveling and then repost the new speed limit based on the 85th percentile speed, which is basically saying that 85% of the vehicles are traveling either at that speed or below. And last but not least, we have a speed that is based on physical characteristics. And so if you have an understanding of what will be designed or what already is existing, You can use those physical characteristics such as the median width or the lane width or the number of access points. You can use all of those things that we know that exist either on that road or near that road to determine the appropriate speed to assign to that road. So to expound on that a little bit more, we can determine the speeds on multi-lane highways using this equation. Now this is the free flow speed, and it's based off of the base free flow speed, which is typically set at 60 miles per hour. And then you subtract off numbers based on what exists or what is known to exist on that roadway, right? So this first one here is a factor for lane width, and the second one is the factor for lateral clearance. That's clearance on both sides, left and right, of the traveled way. And then you have, you can subtract a certain number from 60 miles per hour if the median happens to be divided or undivided. And then if there's a lot of access points, multiple intersections, so to speak, or multiple driveways that can be used to access that main freeway or that main highway, then there will be an assigned number that would subtract from 60 miles per hour, and ultimately you'll end up having a speed that is either at 60 miles per hour or lower than 60 miles per hour if any of these factors play a role in suggesting a decreased speed, which will be calculated at the end. So as I mentioned, you have those different factors, and each one of those factors has a table. You can see the tables here. A factor for lane width, a factor for lateral clearance. You can also have a factor for the median type, and then last but not least, you have a factor for the access points. Going back to the factor of lane width, you can see here that there's a lane width of 12 feet, so that's how wide one lane is. That's ideal, and therefore you don't subtract anything from that 60. If there's a total lateral clearance on a 6-lane highway, so that's 3 lanes in each direction, if the total lateral clearance, say 6 feet on the left and 6 feet to the right, then it's 12 feet. If they add up to 12 feet, then you don't subtract anything, because ideally you want a total lateral clearance of 12. But if their total lateral clearance was only 8, then you would subtract 0.9 from that 60 miles per hour. You can look at the other types of tables, the undivided and divided highways. Ideally, you will want your highways to be divided because you won't feel constricted or due to vehicles that are traveling very close in the opposite direction, and because you don't feel constricted, it would allow you to travel at a faster speed, which is why divided highways you don't have has a factor of 0 when applying that initial equation. And then finally, you got the access points here. The more access points that you have, the more interruptions to flow one would be able to experience. And so, you can have a roadway, right, that's being traveled, and that roadway that's being shown here doesn't have any access points, right? So there aren't any opportunities for vehicles to cut into that roadway or travel in a different direction of the vehicles that are traveling on that road. But if you were to maybe compare that to another roadway, this could be a driveway, it could be an intersection, it could be anything, but that roadway has 3 or so access points along the roadway, then of course that would affect, or it would impede travel and definitely impede speed, and therefore you would subtract the 2.5 or however many is associated with the access points from that initial 60. So let's take a look at this example here. 2 different types of highways, but they're both highways. Look at the first example. It's 12-foot lane highway. So each one of these lanes It's 12 feet. It's 4-lane, but it's a divided highway, so you got a median in the middle. And it's 20 access points per mile. So it could be one of those highways where there's a lot of different establishments, different restaurants, different stores to walk in. You got a bunch of fast food chains and retail stores. And so you can access this location or this highway in many different areas. All right, you got an 8-foot shoulder here, but there isn't any really space necessary here because you have your median. It's like a curved median. All right, so that's one situation. The other situation is another highway, still 12-foot lanes, still 4-lane highway, so 2 lanes in each direction, but it's undivided. Instead of it being a barrier or some type of median, they have these little striped lines, maybe about 2 feet, like those 2-foot yellow striped lines. So 2 feet for vehicles traveling in this direction and 2 feet for vehicles traveling in the other direction. And so altogether, those 2 feet add up to 4 feet. So you got a 4-foot shoulder that's separating instead of a divided median. You got 8-foot shoulders on the right in both directions. It's a rural area, and therefore you have 0 access points per mile. And so having all this information is enough to at least give me a good starting point on the type of speed that I should allow on this roadway. So let's put that down next. Okay, so here we are. We have the 60 miles per hour. That's your base free flow speed. All right, so we're trying to find what the free flow speed is by having first a base free flow speed. And just for highways, is at least for the cases of the examples that we're going to be doing, we're going to always assume it's 60 miles per hour. We're going to start off with that and then subtract off where necessary. So we got the base free flow speed at 60 miles per hour for both scenarios. Look at the top scenario first. The lateral or the lane width is 12-foot lanes. Therefore, that doesn't really affect anything. It's ideal scenario, so we don't subtract anything from 60. The lateral clearance, or I should say the total lateral clearance, that's an 8-foot shoulder on the right side. There isn't much of a shoulder on the left side, and therefore the total lateral clearance in that scenario is going to be equal to 8, and that 8 is associated with a factor of 0.9, and so we're subtracting 0.9 from there. Because it's a divided highway, that's most ideal. Helps with maintaining speeds in both directions. So we subtract 0, and then you have multiple access points, and so for that reason we subtract 5 from that. And so if you're looking at it, multiple access points, we're subtracting 5. It's a divided highway, subtract 0. It's a 4-lane road where we have a total lateral clearance of 8, we subtract 0.9. All right, you'll see something a little bit different for the second scenario at the bottom. At the bottom, we have 12-foot lanes. Again, it's a 4-lane highway, except you got 4-foot shoulders on the left, an 8-foot shoulder on the right, and therefore that gives you a 12-foot shoulder total lateral clearance. And because it's 12-foot total lateral clearance, it doesn't impede the flow of traffic as much, so we subtract 0 from there. The median is an undivided highway, and so we subtract 1.6, and because there's 0 access points, at 0 ends up giving us a nice starting point in terms of the speed of 58.4 miles per hour. And so when you compare the two scenarios, just based on what physically exists, you get 2 different types of speeds. And that is only because the physical impedances create the environment for either a faster speed or a lower speed. And that's just one of the many ways, or at least one of the 4 ways that we discussed earlier of how you can approach setting a speed limit for any one location. And that should be it.